lists of things starting with 0. These days the efficiency isn't the issue, but there's a certain elegance starting at 0, even though intellectually you might think 1 would be the first character in the string. Might make most sense to be sub 1, but it's not, it's sub 0. But just remember that. And so we have this operator called the index operator, and it's square brackets. So, you know, fruit is a variable that contains the string banana, and then fruit sub 1 is the character that's in position 1. Now that actually is the second character. I'll keep reminding you until I get tired of reminding you. And so that assigns A, the letter A, into, the letter A into the variable letter. Of course, that's a badly chosen. It's either a well-chosen variable name or a badly chosen variable name. And the thing that goes inside this can either be a constant or it can be an expression. So this is x equals 3, and then fruit sub x minus 1, well that means 2, which is position 2, which is an n, and so that gives us an n. So the index is an operator, and you can add this bracket syntax to the end of a string variable. You can't index beyond the length of the string, so if I say zot sub 5, well, there's only 3 characters, which means 0, 1, 2, but sub 5 doesn't work, and of course we get a happy little trace back. So you have to be careful when you're starting to pull stuff out of strings. Although some of the things allow it, some of them don't, and then you'll kind of get used to that. We can ask how long a string is. And so we use the len function. We pass the string variable, and we pass it into len as parameter, and len gives us back the length of the string, not the position. So it's 0 through len minus 1. So it's 0 through length minus 1. So length is just another function that we've been doing functions now for a while. You pass in a parameter, and then len does some work, and out comes 6, and that goes back into x because the function has a residual value. It just happens to be a built-in function. And so, you know, somewhere deep inside Python there is code that takes this, and somebody wrote a loop or looked something up and then returned a return value and sent back a 6 to go into our x variable. And so a function is there, and like I said, we've been using this for a while. Another thing we tend to do is to look through strings and look at strings and dig data out of strings. Python is excellent for doing sort of these kinds of lookups. And so we can write a simple loop. We can write a for loop that creates some kind of a iteration variable like index. And given that we know that these positions are 0 through 5, we can set this to be 0. And then write a while loop while the iteration variable is less than the length of fruit. And remember, this is 6, so it's going to be 0 through 5. 0 through 5 are the values we want to generate. And then we can look up one at a time, pull out fruit sub index, so fruit sub 0, fruit sub 1, 2, 3, 4, 5, and then print out the position and the letter index, and then add 1 to index, and it runs. This will run 6 times, 0 through 5, and out we go to produce this output right here. And so that's one way of looping through strings. That is a basic indeterminate loop, but we construct carefully an iteration value, and work our way through that loop data. The other way is to use a determinate loop, a for loop. And generally when we are able to use a while loop or a for loop, all else being equal, we generally prefer a for loop. And so here we have the for keyword and fruit, and it's an in. And so for letter in fruit, well, that just says letter is our iteration variable, and it's going to take on the successive values of each of the characters. So this loop is going to run 6 times, and letter is going to be B-A-N-A-N-A, banana. I'm always terrified when I make these slides that I'm going to misspell banana, because somehow I always think that there are 2 N's somewhere. I don't know. It's not one of my favorite words to spell. I actually didn't choose banana as the constant. The author who I borrowed the textbook from, Alan Downey and Jeff Elkner, they used banana, and so I'm still using banana. So some of the jokes in the book aren't my jokes. They are the jokes of Jeff and Alan. So here are just 2 equivalent so you can have the while loop. They sort of both do the same thing. They both just print the letters out one time through. Each of these loops runs 5 times. But you can see how the determinant loop, the for loop, is a prettier loop, unless you truly somehow need to know this number as you're going through the loop. But if all you're doing is going through and you want to touch in order each of the characters of the string, you then simply write a for loop because it's more elegant. The less code you write, the less chance there is for you to make a mistake. And so the fact that these are equivalent, this is 2 lines of a loop, and this is 4 lines of a loop, that's twice as many places as you could make a mistake, because you might, misspell index or something. I mean, why even make an iteration variable if you don't need to make an iteration variable? And so we can do things that harken back to our iterations and loops chapter, where anything that you can do in those things, like look for the largest letter, look for the smallest letter, search to see if a letter exists, or say count the number of A's in the word banana. And so that's what this is doing. And so we have a counter. So again, we do something at the top of the loop, we're going to do something in the middle loop, and then we're going to print it out at the bottom. So we start our counter at 0, we're going to loop through all the letters, and then if the letter is A, then count equals count plus 1. This is kind of a pattern in a loop where we're noticing something, and instead of like we did it earlier where we said found equals true, well, we're going to count them this time. So if we have 1, we'll get 1. If we have 0, we get 0. And how many ever there are, but there should be 3 because it's going to run 3 times, and there's 3 A's in banana. And so this is a conditional within count. We've seen counts, we've seen conditionals in loop in prior chapters. And so again, I love the in keyword in Python. It again reminds me of set notation in algebra. If you're a math whiz, if you're not, don't worry about it. Or maybe you will be a math whiz and you'll say, whoa, this set notation reminds me a lot of the in keyword in Python. So again, it's for iteration variable letter. Again, don't get stuck with letter. I just happen to be using it here in banana. And that is for each character in the string banana. Run this loop once, changing the variable letter to be the particular character that we're pointing at. And so it's taking care, for is taking care of a lot for us, right? And so this is sort of this really smart for loop. The for loop is, both deciding how many times to run the loop, in this case 6, and it's advancing the letter. So advance, print, decide whether you're done, 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 advance, print, decide whether you're done. I am now done because we're done with that particular string. And so you can think of the for as, magically doing all of this for you, of both deciding how long to run the loop, when you're done or not, and moving down through all the successive letters in the loop. So up next we'll talk a little bit about additional things that we can do with strings. So now we're going to dig into strings a bit, and we've already looked at how you can pull out a single character in a string, and now we're going to look at what we call slicing, and that is pulling chunks of a string out. And again, we're going to use the square bracket operator, and so S, and the way I say it is sub, S sub 0 through 4, that's how I read this. S sub 0 through 4. So I look at the colon as through, I look at the brackets as sub. And so S sub 0 through 4 says start at position 0 and then go up through, but not including 4, right? So we don't include 4. So that's probably the hardest part of this. Up to, but not including. Up to, but not including. This seems counterintuitive, kind of like starting at 0 seems counterintuitive, but after a while, you get used to it, and there'll be situations where you're writing code like, oh, that's why that works better. But just for now, remember it. Up to, but not including. It's just kind of a little thing. We'll come back to when that is useful for us. 6 through 7, well, that ends up being starting at 6, up to, but not including 7. So that's why we only get the P out. Now, one thing that Python is pretty nice about is it's not going to give you a trace back. we might expect that 6 through 20, well, there's no 20 characters, but it's like, that's okay. We'll just let you stop at the end, and we'll start at 6 and go all the way to the end. Oh, no traceback. It's almost disappointing.